Hello everyone, this is Siddharth, and in this video we will be solving another question from the list that I have shared in the starting of this playlist. If you don't know what we are doing in this playlist, we are solving all those questions which are related to each other, so that we can able to build intuition and able to solve those questions as well which are related to these concepts, and we can solve those questions very easily if we have already solved these type of questions. So let's start solving this question as well, and I will put the link of this playlist that I am making on my YouTube channel in the description as well. And also I have made the full documentation of these questions and about this playlist on my GitHub account as well. You can check it out that as well. So let's start solving this question as well, that is reordered list. So what we have to do in this list, we have given a linked list, and we have to reorder according to the condition that we have given. And the condition is we have to connect the zeroth node with the nth node, then one node one th node with the n minus one node, and then L2 to n minus 2th node. So let me make you understand this. That is 1 2 3 4 first uh, is our first linked list. So 1 is connected to 2, and 2 is connected to 3, and 3 is connected to 4. Now what we have to do, we have to make this linked list as so that this is n minus 1th node, this is n minus 2, this is n minus 3, and this is 0th node. So, or we can say n minus n. So now what we have to do, we have to connect this 1 with 4, then 4 with 2, and 2 with 3. Now let's take another case as well so that you can understand. That is 1 2 3 4 and 5. So 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to 5. Now what we have to do, we have to connect 1 with 5, then 2, then 4, then 3. Sorry. So 1 5 2 4 3. So 1 5 2 4 3. This is what we have to do. Now if you will try to observe what we are actually doing here, we are just dividing our original linked list, and then we are reversing this linked list and then connecting it. Let me tell you. So 1 and 2, and then 3 and 4. Now what we have to do, we have to reverse this. 4 is our new head now, and 3 is our tail node. Now this is 1 and 2. Now what we have to do, just place them each other like this, or we can say 3 is pointing to 4. Now what we have to do, we have to just place them, that is 3 is pointing to 4, or we can say 4 is pointing to 3. We can say that we have to just put this 4 here and 3 is here. So this will look like 1 is pointing to 4, and then 4 is pointing to 2, and then 2 is pointing to 3. So this is what we have to do. So two concept, or we can say two condition that we have to do, or we have to check, that first we have to divide, or we can say split the linked list in two halves, and then we have to merge these two linked list. And this 4 is the tail node, so we have to connect smaller linked list uh, tail node to head of bigger splitted linked list. So this is what we have to do. Now for these two, we can use, for the splitting the linked list, we can use the tortoise algorithm, which I have taught you already in the first video of this two pointer series, where one pointer is fast and another pointer is slow. So this is that first question. I think that is like second, or we can say if we will talk about overall, it will going to be 37. I think you can check it out. That is linked list cycle something, where that there I have used slow and fast pointer, and slow will be moving one step at a time, and fast is moving two step at a time. So this will ensure that slow will come in the mid, let me tell you. So 1 2 3 and 4. So fast will move here, so slow will move here, and then fast will be here, then slow will be here, and then fast will be here. So slow dot next, and then fast dot next, and then slow is equals to slow dot next, and fast is equals to fast dot next. So it will be pointing to the last, but we have to check so that it will not pointing to the null, because 1 2 3 4 is our array. So we have to reach, or we can say we have to reach to the middle element of the array, and for even number it should be one greater than the middle, uh, or we can say modulo of this length of this, modulo of the length by 2 plus 1. So this is what we have to reach so that we can split this linked list into like this: 1 2 3 and then 4 here. Now what we have to do, we have to just connect it with the head of the original linked list. So this will look like 1 4 2 3. Okay, so now what we have to do, after finding this middle, we can reverse the second linked list and then merge with the first one. So this is what we have to do. So I think now it is clear to you how we will be solving this question. First, we will be splitting the linked list in, or a linked list into two halves. If the length is even, then one the length of the first linked list will always be greater, and if they are odd, then both will going to be of same length. Okay, so now let's try to solve this as well. So first, what we have to do, we have to apply the tortoise algorithm to find the middle element. For that, we have to make two nodes: list node slow, it will be pointing to head of the linked list, and then list node fast, it will be pointing to the head as well. Now we just have to use a while loop. While fast dot next, sorry, does not equals to null, then what we have to do, we have to we have to move our slow pointer one step and fast pointer two step at a time. So fast dot next dot next. Now after doing this, our slow will be pointing to the middle element. So now what we have to do, we have to start reversing the second splitted array. For that, we have to first split it as well. So here we will be using a standard method to reverse and linked list. If you don't know, let me tell you that as well. So suppose this is a linked list and we want to reverse this. 2 is connected to 3, 3 is connected to 4, 4 is connected to 5. So we will make 3 pointer: previous, and then current, and the next node. So previous will going to be null, and then current will going to be this, and next node will going to be 3. Now we will point this current element to the null, and we will move our current element to this and previous to this. Now we will do the same for this. We will point 2 is pointing to null, and we will point 3 to 2, and then we will do the same until our current element will reach to the null of this original linked list. And this is how we can reverse the linked list. So this is what we have to use here as well. So list node current is equals to, it will be pointing to slow dot next. As it is pointing to 3, we have to move it to the next element, or for this case, slow dot next and fast dot next dot next. And here fast dot next is not null, so slow will be pointing to this. Then we just have to move our current to slow dot next. Now after moving our current, we have to make a previous node as well. So list node, oh, let me make it small. So list node previous, it will be pointing to null in the start. And then what we have to do, and the next node we can make inside the while loop. First we have to break the linked list as well. So for that, we can use slow dot next is equals to null. So this will break this linked list. For the first, it will be 1 2 3, and 3 will be pointing to null. So our two linked lists will look like 1 2 3 and then 4. So these are the two linked lists. Now what we have to do, we have to like start reversing it. So for that we can use while current does not equals to null. What we have to do, we have to start reversing it. So for that we have to make an next node. So list node is equals to next node is equals to, it will be pointing to current dot next, and then we have to point the current element to previous. So current dot next is equals to previous, and then we have to make current element as previous. Oh, sorry, previous will be pointing to current, and after that, after pointing previous to current, we have to point current element to the next node. So if you are not getting this, let me tell you. So first, what we have done, we have point this current element to the null, and then to the previous, and previous is equals to null, so automatically this will be pointing to null. And then we have made our previous pointer to current, because if there are more elements here, then we have to do the same for that. That's why we are pointing previous to the current element, and then we will be like pointing our current element to next node, so that we can do the same for all element. So this is what we are doing here. So after this, our linked list will be look like this. Let me tell you. For this case, it will be the same, but for this case, 1 2 3 4 5, it will look like one. So slow dot next, fast dot next, uh, slow dot next, and fast dot next, then slow dot next, fast dot next. So slow will be pointing to this. So this will look like 1 2 3, and then 4 and 5. So now what we have to do, we have, after this step that we have just done, this will look like 5. uh, 4 is pointing to 5, so 5 should be pointing to 4, and now we just have to insert it here. So we have to connect 1 with 5. So for that we can merge these two, or we can, let me comment it out, merging two splitted final linked list. Okay, so for that we can use another standard approach. Let me tell you that as well. So 1 2, suppose we have to merge these two as well, so 4 and 5. So what we can do, this is our first pointer, this is our second pointer. Now we have to make two additional pointer as well. Now what we have to do, we have to point this 1 to 4, then 1 to sorry 5 is pointing to 4, so 1 to 5, and then as 5 is inserted here, now we have to point 2 to, sorry, we have to point 2 to 4. This is what we have to do. So this will look like 1 will be pointing to 5, then 5 will be pointing to 2, sorry, this will going to be 5 will be pointing to 2, and 2 will be pointing to 4. So 1 5 2 4. So this is what we have to do. So for that we have to initialize two pointer. So list node first first, so this will be pointing to the head of our original linked list. Then another list node will going to be the second one, that will be like head of the second splitted linked list, and that will be previous, as this previous will be pointing to the last node, and which will going to be the head of our second linked list. That will going to be 5 in this case and 4 in the first case. So now let me tell you how we have to do this. Now as second array is always small, so we can use that condition while second does not equals to null. So this we can use, as the second array is always will going to be, second linked list will always going to be smaller. Now what we have to do, we have to make two temp node as well, which will be pointing to the next element of the current first and second element. So list node temp 1, it will be pointing to first dot next, and then list node temp 2, it will be pointing to second dot next. Now what we have to do, we have to point the second element, oh sorry, first element, first dot next to second. Why? Because previous is 5, or we can say second is 5, and one is first, so first dot next will going to be second, and then second dot next should be this temp we have just made. So second dot next will going to be temp 1, and this is the second element of the first array, first linked list. Okay, and then we have to do for the next element as well. So for that we can point our first to temp 1, so that we will able to do the same for the next element as well, and then second to temp 2. So this will ensure that we can able to do the same for the next element as well. And here we have like modified the linked list. Now we can try to run this. Okay, so there is an issue, let me see. Okay, so we have to check for the test base case as well. If head is equals to null, or head dot next is equals to null. In this case we just have to return. So now we can run this. Okay, so there is another issue, let me see. Okay guys, so we have to check for the fast as well. So fast should also not equals to null. So we have done it by mistake. Now we can try to run this. Okay, so all the test cases have been processed. Now we can submit it as well. Okay, so we have successfully solved this question. See you in the next video. Bye.